Okay, so let us do 4.1 related rate. Okay, so this section is about kind of rate of change, right? But then look at the title, related rate. So their rate is related each other, okay? So they talk about related quantity. Quantities are changing with respect to time. Okay, so they talk about the balloon, right? So we have a balloon. Then we're gonna call balloon. So dV over dt, the volume change respect to time. This means, okay? And dr over dt, the radius change in respect to time. Okay, and then also they are related to each other because volume change when radius change, right? Okay, so we're gonna do that, this section. So every time we using the variable, every time over the t, because it's changing about the time, respect to time, all right? So let us do this one first. Find dy over dt at x equal to 1 and y equal to x squared plus 3 if dx over dt equal to 4. Okay? All right. So we're going to use a chain rule every variable from now on for this section. Okay? So we want the derivative here, dy over dt. Okay, we want to find derivative with respect to time. Okay, then what do you get this one? With derivative, x variable. What? What?
Is it just 2x?
2x, right? But then before, when we derivative x, we just leave like that. And then we do implicit differentiation about the y, right? Well, in this section, we're gonna do differentiate chain rule as well, even x. So we're gonna make this one dx over dt. Okay, then look, given information, when x equal to 1, so we substitute there. And dx over dt equal to 4, we substitute there. Okay. Okay. So then the answer is dy, oops, dy over dt, which is 2 times 1, dx over dt, which is 4. What do you get this one? I know, 8. You don't have to tell me. Okay, good. Thank you. All right, so let me erase this one. Let me see. Okay, so hey, let me draw. Okay, so this balloon change, right? Ooh. Say, So volume change when radius increase, right? And volume change when radius increase. Volume change when radius increases. Oops. So look, let me write down here as balloon the balloon is being filled with air of the radius and the volume are increasing. With what? With respect to time, right? So make sense? So we're doing with respect to time, okay? All right, so then let us read the application. What is this? What is this? And also, what is this? And then what we are looking at. So if we don't know anything, then we are looking at the unit as well, right? So this is a cube. Then what do you think? Cube there. Cube, volume, right? So volume of a sphere, let me write down. 4/3 pi r cube. Okay, so this is the volume of a sphere. Okay, it's a cube, looks like a cube. Let me see. Okay, so we are looking at how fast the radius increasing, right? So this is the rate, right? So we called this is dr over dt. Okay, then radius equal to 3 centimeters. So r equal to 3 centimeters, right? Is okay? So our goal is dr over dt. Now, how do you find this one? So we will derivative. Okay. So let me write down this is dv over dt. All right. So we derivative this one. So d So d over dt, v equal to d over dt, 4 over 3 pi r cubed. Okay, so we do derivative with respect to t, but every variable we're using chain rule. Okay, that is the main idea in this section. So we derivative v respect to t, what do you get? So like implicit differentiation, when we differentiate y, we differentiate as a function of x, right? Then we make a chain rule, right? Same as here. So we do derivative v respect like a t in this case, right? But then we make a chain rule. So what do you get this one? Yeah, what do you have? So we do dv over dt. Make sense? Okay. Equal to, we derivative, in this case, r, right? So we derivative r, what do you get? Think about the chain rule later. We derivative r.
Um, 4 pi r cubed
4,
squared, I mean, 4 pi r squared.
3 pi, then drop the 3, right? And r squared, you said? And then since we derivative r respect to t, so we're gonna make a chain rule, which is dr over dt. Okay. Now, we have information, everything. So what is the dv over dt in above, right? It's a 2. So let us do no space. Let us do this one. 2 there. And then we simplify. So we have 4 pi. And then r, which is 3 squared, correct? Okay. And the r over dt will be, we're going to find. Okay. Then what's this number? So we can divide. So I'm sorry, 3 squared, 9 times 4, which is 36. So we divide by this number, right? Then we get dr over dt. So 2 over 36 pi, which is 1 over 18 in unit centimeter per second. So this is how we find how fast the radius increasing when radius, in this case, in this problem, is at 3 centimeter. Is okay? It's good? Okay. Let's move on. Very good. Okay, example number 3. So let us do rocket launch. So, Okay, so let us read this one. Look. So we level 5,000 feet from the launch pad. Okay. Now, what's the goal? We're gonna read the last sentence, right? So find the necessary rate of change of camera's angles. So rate of change camera's angle, right? So our goal is the theta over the t because they said as a function of time, right? So let me this one. So goal is the theta over the t. Okay, now how do we find from I'm standing here, right? So in terms of angle theta, which trigonometry function we have to use? Only that given information for now.
Tangent.
Tangent, good. Okay. So we're gonna use 1,000 feet later. Okay. So this is h later. I don't want to label now. How about like this? Call d theta over dt when h equal to 1,000. Okay. All right. So your classmate say that tan theta. Okay. That is sine over cosine, that is opposite over adjacent. So let me denote it this way. Okay, so this is h over 5,000. Okay, now we're gonna make a derivative. Okay, so let's see. So let us using, sorry for h for now. Oh, we did not cover this one. My IC is not good. So velocity is 600 feet second per second. What is called? So we're not using dv like velocity, okay? In this case, we're gonna use this one is range, right? So we're gonna use this is dh over dt. It's okay. So let's go back to the equation. So we're gonna solve for h. Then we will have h equal to 5,010 theta. Now we're gonna derivative respect to time. Uh, 5,010 theta, right? All right, so left side, what do you get? We did
dh over dt.
yes, so we have dh over dt. And then right side, what do you get?
5,000 secant squared theta times d, what would the d be there? D
d
what?
theta dt. Good.
Okay.
So secant squared theta d theta over dt. Okay. All right. So we know what's dh over dt. Okay. Now, our goal is finding d theta over dt, right? But then we need to find what is the secant squared theta, right? So look, let me erase in this case. So we have a right triangle here. I just erased this one, right? So I should have used that one. Why I erase? Okay. So we have 5,000 earlier, and then here we're gonna use this information here, 1,000, and then we want to know about the C. Okay, then how we find? So C square, which is 5,000 square plus 1,000. Okay, then squared, missing squared. Now we have C equal to, what do you get? Can you please calculate this one? Simplify. 6,000, 6,000. So let me just book then. How about that? So we have 1,000 square root of 26. Yeah, it's good. It's all right. That's nice. Okay. But then people try not to carry the decimal because when they write, they lose the digit often, right? That's why. All right. So now, secant, let me write down on the left side, the top there, because no space. So we have secant theta first, then we make a square them later, then we can find. It's 1 over cosine theta. So cosine is Jason over hypotenuse, right? So it will be hypotenuse over Jason. So if we have angle theta there, I'm standing. So hypotenuse will be C, which is 1,000 over, not over, 20, square root of 26 over Jason, which is 5,000, right? Okay. Then we need the secant squared of theta, right? So let us square that. Okay. Then we simplify. So inside 3 zeros, simplify. Then 1/5 square, then 25. Then there is the 26, right? So we get 26 over 25, right? Okay. Correct, right? Okay. So we did that. So let us write down everything. So our goal is d theta over dt. So look, dh over dt, which is 600 feet per second, right? So we have that. And then secant square x, not x is a theta, we have that. And d theta over dt, right? Then d theta over dt, so 25 over 26 and 5,000. So 25 over 26 and 5,000. Okay. So then, can you simplify this one? d theta over dt, which is can you simplify? So let me use a book. So we have, let me see, 3 over 26. Okay, so unit is radius, not radius, radians, because we talk about the angle, okay? Radians per second, because time, okay? Okay, so let us read this one. And what is it telling us? Now we know what is this, right? What is that? If we don't know, we can use
dv over dt.
So we can looking at the unit, right? So this is dv over dt. Then we already label the height, right? And then we already label the top of the funnel. Funnel is the 1 feet. Okay, the radius. I'm missing that. So here we're gonna use volume of the cone, right circular cone, and also similar triangle. Okay, so let me write down the volume of right volume of right circular cone. So that is the V equal to 1/3 pi r square h. Okay, now we're not doing the derivative yet because we're gonna use the information. So here, the similar triangle, look the ratio, look at the ratio. Let's see. This one, that one, R over H, then 1 over 2. Can you see that? The ratio? So either one, it's okay, but make sure you do right one. So R over H, okay? So we make it equal to, so R is the radius, which is 1, the height, which is 2. Or you can do vice versa, like H over R, then you can do the 2 over 1, like that, okay? Now, solve for R because we're going to substitute there. Okay, then look, we like a cross product, right? So this is 2R equal to H, right? Then R equal to 1 over 2 H, right? So we substitute there. Okay, then we have V equal to 1/3 pi 1 over 2 H quantity squared H. Okay, that is V equal to, we have pi, I'm sorry, that is the squared, which is 4 times 3, which is 12, right? So it's 12 pi H cube. Okay, now we're gonna derivative. So we do derivative, let me using here, respect to t. So what do you get this one? Oh, why I have H. Sorry, something wrong. Hold on 1 second. So that's a 2, 4, right? So this one should not be H cubed there, right? So derivative of V, left side, respect to t, what do you get?
dv over dt.
dv over dt. Now we do derivative h respect to t. What do you get?
Pi over 4 h squared times dh over dt.
Excellent. So we drop the power, right? Then h squared, then the dh over dt. Okay. Then let us substitute dv over dt, which is we have a 0.03. And then we have a pi over 4. H equal to 1/2. Okay. So we are using h for here. So let me see. 1/2, oops, squared. Then dh over dt. So squared is 4, so pi over 16, right? So we do pi over 16. So 16 over pi times 16 over pi. Then we get dh over dt. So what do you get this one? Can you please calculate? Sorry, I'm missing negative sign. So it's draining. So I'm gonna use the negative sign. So we don't have a negative sign there, right? please calculate this one? So it's 0.03. Okay. And then way of note. It's draining. So negative 0.03 feet cube second for the dV dt. Okay. So I'm gonna use negative sign there. Did you calculate this one?
The answer is negative 0.1528.
Thank you so much. The unit is feet per second. Okay. So height, this is the height of water, is the funnel of changing. In this case, when height is 1/2 feet. Okay. Okay, so let me write down the surface area of the cylinder formula. Okay, it's a 2 pi r squared plus 2 pi r h. Okay, let me denote S surface area as S. Okay, all right. Then we have to know what what's the radius. Okay, but then in this case they give us the diameter, right? Then how do you find the radius?
It's half the diameter.
Yes, so it's 11 in this case. Okay, how about this is the height, this is h, and then what is this? So what is this? Negative 4 meters per second.
Sure, if you could call it volume because it's surface area, so I'm not sure what you would call it, but something is changing.
Well, unit. Looking at the unit.
The unit.
And then they say that on the top too. If the diameter decreases at an instantaneous rate of,
Would it just be dm over dt?
okay, so this will be, we're gonna use as dr over dt, but in this in this case, diameter, right? Okay, then how we make radius?
Oh, would it be dr over dt?
Yeah, so we're gonna make dr over dt, which is negative 2 meter per second. Make sense? Okay.
That half too.
Okay. So then What is this? What do you have to set it up, this one?
dh over dt.
Excellent. You there, huh? I didn't know you were there. Okay, so then let us derivative respect to t. So let me use it as like a surface area equal to, so 2 pi r squared plus 2 pi r h. Okay, okay. We do derivative with respect left side. We do derivative as respect to t. What do you get?
dh over dt equal
Excellent. And then with the derivative, respect r in the first term,
4
respect to t.
pi r dr over dt.
The r over dt, good. Plus, second term, we
Um,
have r there, we have h there.
2 pi dr over dth.
So we're gonna use product rules, f prime g plus f g prime. Good. So we have 2 pi dr over dt plus, I'm sorry, missing h, yes, missing h, and plus second term f, 2 pi r, then g prime, what do you get?
d dh dt.
dh over dt, excellent, okay? All right, just plug in, substitute, because we need to look for the rate of surface area, right? So ds over dt, which is 4 pi r equal to 11. And dr over dt, which is negative 2, plus 2 pi dr over dh, no, dr over dt, which is negative 2. H is, where is it?
28.
28, right? Thank you. And plus 2 pi r, which is 11, right? Okay, then dh over dt, which is 2, right? I don't make a mistake, right? Okay, so now your turn. Can you please calculate everything? Negative 2, where?
Negative 156 pi.
You said a negative 100?
156 pi.
Okay, everything,
Yeah, everything.
not pi. Everything. Meter squared per second. Unit is important too, right?
Negative for 490 uh 08845.
Okay, thank you. So this is the final answer, okay?
cm is not m. cm.
This is M, meters, 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 meters.
But for the homework,
Mhm. It depends on the individual. Let me erase.